Hello guys, welcome back to the channel Mathemagix JEE. This is question number 6 of the paper 1. Okay, it is again a multiple correct type question. More than one options may be correct. So let us solve this question. Let n denote the set of all natural numbers, okay, and z denote the set of all integers. Okay, consider the functions f defined from n to z and g defined from z to n, defined by this and this. Okay, these two definitions are there for fn and gn. Define g composite f n as g of fn for all n belongs to natural number. Okay, and f composite g as a function of n like this, f of g of n, right, for all n belongs to the set of integers. Then which of the following statements is oblique are true? Okay, so first we have to study the behavior of this function f and g. Okay, then we can find the functions f of g and then find the function g of f. Okay, by the definition of f and g function, then we can solve all the four options. So the most easy options here will be option C and D. Okay, first we should check them because this f and g are straightforward given in the question statement. Let us check f first. Okay, so we are checking option D first. F is not 1 1 but f is on 2. So let us find some values of f of n for n equal to 1 2 3 so on. Okay, to understand the function's behavior. So if we draw a table here, let's say we are plotting n versus f of n. Okay, so in 1 2 3 4 5 6 7, let's count up to 7. Okay, so n we are starting from 1 because f is defined from the set of natural numbers. Okay, so we have f of 1. If we solve this, f of 1 will be n equal to odd, right? 1 is odd number, that means this definition will work. So f of 1 will be 1, right? Then it will be, if we put n equal to 2 here, f of 2 will be this definition, right? Because 2 is an even number, that means 4 minus 2 by 2, that means 1. Okay, then we have 3. So again this definition, 3 plus 1 by 2, that means 2. Then for 4 it will be 0, right? Then it will be, if we count for n equal to 5, it will be 3, right? And then for n equal to 6, this will be minus 2 by 2, that means minus 1, right? Now for n equal to 7, we can similarly say that it will be 7 plus 1 divided by 2, that means it will be 4, right? So we can see the pattern. For n equal to 8, it will be minus 2, right? So we can see here it was 0, right? Here it is 1. Here it increases by 1 for the next odd number. Okay, then for the next odd number, this again increases by 1, then so on. That means we have got the pattern like this. So if we increase the value of n, we get 2 3 4 so on, all positive integers. Okay, after 2, and then we have this 1 here because we got this, and here this 0 is there, right? And then we have again all the negative numbers, that means minus 1 minus 2 negative integers, I would say, minus 3 so on. Okay, so we can see this list contains all integers. That means this codomain, which is the set of all integers, is equal to the range of this function. That means f is on 2. Okay, so then if we check for the 1 1 nature of this function, we can say f is not 1 1, right? Because here we have this counter example, this thing, for n equal to 1, f is 1, and n equal to 2 also gives f equal to 1. That means f is not 1 1, right? So we can see option D is going to be definitely correct option, right? So let us check the C option, which is based on the G function. So G function, if we plot the table for n versus gn, we get, so here are the values of n. Okay, like this. Then if n is greater than equal to 0, gn is 3 plus 2n, right? So we can see here we have got all the odd numbers, right? Because for n greater than equal to 0, this will be 3 plus 2 times n. That means this is an odd number and it is some even number. And if we sum even plus some odd number, we will get a odd number, right? That means we have here this gn as some odd number for n greater than equal to 0, right? So for n less than 0, we have got all the even numbers, okay, in natural domain. That means we have got the even natural numbers. Now let us put the values of n to determine whether gn covers all the natural numbers or not, so that we can determine whether g is onto or not. So let's check. Let's check for n equal to minus 4, okay, then minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, okay. So let's check. If n less than 0, that means this definition will work for gn. So gn will be minus 2 times minus 4, that means 8, right? This will be 6, right? So this will be 4, this will be 2. And for n greater than equal to 0, this will be 3 plus 2n. That means this will be 3, then it will be 5, 7, 9, 11, right? So we can see the pattern here, that this 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the numbers are covered, right? But this 1 is not covered, right? 1 also belongs to the set of natural numbers, but it does not appear here, right? This 1 is not found in any of this gn values, okay. That means 1 does not appear here. So the range of the function is not equal to the codomain of the function, which is this natural numbers, okay. That means we have this codomain not equal to range of this function. So we can say g is not onto. So if g is not onto, this option is definitely wrong, right? Because here it is and link, okay. For and link to be true, we have to have both of the statement to be true, right? Now see, here we have to check this a and b option, okay. So we have to find the functions g of f and f of g, okay. So let us find them. Let us try to find g of f first, right? So g of f, we can say, will be g of fn, right? G of fn will be, by using the definition of gn, we can say this will be 3 plus 2 times fn when fn is positive or equal to 0, okay. Then we have this equal to minus 2 times f of n when f of n is negative, right? So now let us count the possible cases when this f of n is positive or equal to 0 or negative, right? So we can see from the definition of fn, this n is a natural number, right? So that means this number is never 0. This is equal to some positive number, right? This number n plus 1 divided by 2 is always positive, right? For n belongs to natural number. But this number can be both positive, negative, as well as equal to 0, right? So it will be negative if n is greater than equal to 5 and positive if 1 less than equal to n less than equal to 4, right? Sorry, this will be less than equal to 3, we can say, right? Because for n equal to 4, this is equal to 0. So that means we can say for this case to hold true, 3 plus 2 fn, if and only if f of n is greater than equal to 0, we have to take two possible cases. That is this case here, positive if 1 less than equal to n less than equal to 3, right? And then we have to take this case if n is odd, okay. So let's solve. So we have this g of f of n equal to, then we are breaking this into two parts, okay. So it will be 3 plus 2 times this definition of fn 2 times n plus 1 divided by 2 if n is odd. If n is odd, right, then we have this definition that if n equal to 4 minus n divided by 2, that means this will be 3 plus 4 minus n, right, when 1 less than equal to n less than equal to 3. And for this if n equal to 0, that means n equal to 4, this is also true. So we can say this, if we include here, that will be no problem. Okay, so 1 less than equal to n less than equal to 4, if this is true, we have g of fn as this. Okay, for both of these cases fn is positive or equal to 0. Now let's analyze the case fn less than 0. Okay, so fn less than 0 is the case this, right, negative if n greater than equal to 5. That means we have to also take care of this case, right, this n is even, right. So let us include this case also, and n is even. Okay, and n is even and n greater than equal to 5. This case will lead to this fn less than 0, that means this definition will work, right. So it will be minus 2 times f of n. So f of n is 4 minus n divided by 2, that means this will be 2 times n minus 4 divided by 2, right. So this will be simply n minus 4. So this, if we simplify, this will be 7 minus n, right, and this will be simply n plus 4. So g of fn we calculated as this function. Okay, this is the definition of g of fn. Now let's analyze the characteristics of g of fn. So if we draw a table here similarly, right, so n is natural number. So 1 2 3 4 5 6. Okay, so then if we put n equal to 1 here, n is odd, right, so n is odd means this definition, so this will be 5, right. Then n equal to 2, so n belongs to this range, right, 1 less than equal to n less than equal to 4, and n is even, right. So this will be 7 minus n, that means 7 minus 2 equal to 5. Then if we put n equal to 3, this will be, this n is odd definition, right, so this will be 7. Then we have n equal to 4, that means this definition, right, n is even and n less than equal to 4, that means this will be 7 minus 4 equal to 3. Then n equal to 5, so n is odd, right, so n is odd means this definition, so 5 plus 4 9. Then we have n equal to 6, so n is even and n greater than equal to 5, that means it will be 6 minus 4 equal to 2, right. For n equal to 7, what will be the case? Okay, let us analyze this for n equal to 7 8 and 9 and 10 also. Okay, so 7, it will be n is odd, right, so 7 plus 4 equal to 11. And then we can say similarly for n equal to 9, it will be 13, right. Then for n equal to 8, it will be this definition, right, so 4. Then we have 10 minus 4, so it is 6, right. So we can observe a pattern here, right, that this is 2, this is 4, this is 6, that means the next number for n equal to 12, this will be 8, right, then it will be 10, so on. So all the even numbers. Then we have this 5 7 9 11 13, right. So we have how many numbers in our range? Let us count. So we have this 2 3, then we have this 4 here, then we have 5, then we have 6 7 8, yes 8 will be there, right, then 9 and so on. But now see that we don't have this 1 in our range. Okay, this 1 is again missing, because this g of fn is defined from what to what? This is defined from n to n, right, because this f of n is defined from n to z, right. Then we have again g defined from z to n, so we have something like this. Okay, so g of f will define from this to this, right, n to n, set of natural numbers to set of natural numbers. So we can say we must have this 1 in our range for this function to be an onto function, right, but we don't have 1 in our range, that means this function is not onto. So we can say clearly g of f is not onto, right? And checking about the 1 1 nature, we can see this function is again not 1 1, because for n equal to 1 and 2 the functional value is same. That means we don't have this function as a 1 1 function. So g of f is not 1 1 and g of f is not onto. This statement will be definitely correct. Now coming to B option, f of g. Okay, so f of g we have to determine. Let's find this. F of g of n will be equal to, if we look into the definition, it will be gn plus 1 divided by 2 if gn is odd, right? So gn plus 1 divided by 2 if gn is odd. Then we have this equal to 4 minus gn divided by 2. So 4 minus g of n divided by 2 if gn is even. Okay, so now we have to take cases where gn is odd and gn is even. Okay, we have to analyze the gn function. So gn, if we look here, we get that for n greater than equal to 0, this function is definitely giving some odd value, right? 3 plus 2n will be definitely a odd number, right? We just discussed that even plus odd is always odd. So this will be an odd number. But for n less than 0, this will be always a even number, right? So this will be, if we take the cases, gn is odd means n is greater than equal to 0, and gn is even, that means n is less than 0. So we have the definitions for n greater than 0, greater than equal to 0. If we check for the definition of gn, this will be 3 plus 2n, right? So we can replace this gn with 3 plus 2n plus 1 divided by 2 when n is greater than equal to 0. And for this we have gn equal to this definition. Okay, so this will be minus 2n. So this will be minus and minus plus 2n divided by 2. Okay, for n less than 0. So this will be, if we calculate, 2n plus 4 divided by 2 in both the cases, right? So n plus 2 will be for n greater than equal to 0, and also again n plus 2 for n less than 0. That means f of g of n is n plus 2 for all n belongs to the set of integers. This is the definition of f of g of n, right? So we can say that this function will definitely be a onto function, right? Because for example, if we put n equal to something m, this is some integer, then this will give f of n equal to, this will be m plus 2, right? And for n equal to m plus 1, which is the next integer above this, then we have f of n equal to m plus 3, right? Just the next integer after this m plus 2. That means we have got all the integers covered, right? So all the integers are covered means if the codomain is equal to the set of all integers, we have the range equal to also the set of all integers. So codomain equal to range, that means this f of g function will be onto, right? Now coming to the 1 1 nature, this function is definitely 1 1, right? Because for every integer n, we have a distinct value of f of gn. So this is definitely 1 1. So this function is both 1 1 and onto. Now the B option is saying f of g is not 1 1 but f of g is onto. This is not going to be correct, right? Because f of g, as we saw, is 1 1 function and f of g is also onto. That means this option is incorrect. So our correct options in this case will be option A and option D. So this was a very good question on the definition of functions and the composite functions. Okay, and I think this pattern of defining functions like this and then uh, asking about the composition of functions has become a very favorite part of JEE. So the upcoming aspirants who are preparing for 2026 or 2027, you have to practice this type of questions in a very good amount, right? Because this type of questions do occur in JEE mains also. In JEE main 2022, I remember this type of questions occurred. Okay, so you have to be careful.